Good morning. I'd like to welcome you to today's version of the conference and today's discussions about how we're going to take Drawdown from describing climate solutions into implementing them around the world. My presentation today is going to be focusing a little bit on the next stages of Project Drawdown's work. How can we take climate solutions from description to implementation? And let me go ahead and share some slides with you to illustrate some of these ideas. So as we describe how to take climate solutions from theory to practice, we have to remember kind of what Drawdown is all about. The idea, of course, is to stop the climb of greenhouse gases. If this is where greenhouse gases are today, we might continue to have them elevate, increasing the levels of climate change into the future, causing more and more disruption to our planet and to our civilization. We don't want to do that, of course, and we want to essentially bend the curve. As epidemiologists are talking about with COVID, we need to do the same thing with climate. And of course, Drawdown refers to this moment in time. Drawdown does not refer to carbon removal from the atmosphere. Drawdown refers to leveling off and then declining eventually the level of greenhouse gases. So Drawdown's a moment in time, it's not a carbon sink. And it's when we stop the climb of greenhouse gases and have them steadily decline, and that's when we begin to stop climate change into the future. But to do that, we have to start basically by looking at the atmosphere, because the atmosphere is kind of the ultimate arbitrator of our solutions. It's the best accountant on earth. It takes into account everything that goes in, everything that goes out, and tracks every single molecule perfectly. So when we want to solve climate change, first start with the atmosphere. The atmosphere, of course, is going to be changed by our human activities. This is on the left-hand side, the emissions of greenhouse gases that we are causing around the world. About a quarter of them globally come from producing electricity, about a quarter from the food system, kind of clearing land, methane from animals and rice fields, nitrous oxide from fertilizers, and a bunch of other things. We have industry, we have transportation, we have the direct emissions from buildings. Buildings, of course, also use electricity and materials, which are accounted for elsewhere. And then we have the remaining 10%, which is kind of everything else, but mostly in the energy fields themselves. So that's what we're pouring into the atmosphere. And of course, we have to tackle that part of the problem very, very directly. But the atmosphere is not just happening by itself. We're not just the only things responding to the atmosphere and it's responding to us. We're also seeing natural processes, especially carbon sinks that are in nature. Right now, not yet us, but entirely in nature, on land and in the oceans. And interestingly, nature, basically forest and oceans, remove roughly 41% of the greenhouse gases we put in the atmosphere, primarily the CO2 parts of that, and leaving behind 59% building up each and every year, accumulating in the atmosphere, causing more climate change. To achieve Drawdown, we have to look at both sides of this equation. Most important, of course, and we have to do first and foremost is bring the sources to zero. Stop pollution before it even gets into the atmosphere, because the moment it's in the atmosphere, it starts to accelerate climate change. We have to reduce those sources to zero. In the meantime, we also have to support and perhaps even augment natural sinks that continue to remove the historical existing emissions of greenhouse gases, especially CO2, but maybe others in the future, and remove them slowly from the atmosphere. And this is the physics of the problem. We've got to start with the sources because those begin climate change. Sinks are not the same because they only remove pollution later, often decades later. And that's something we need to do to kind of clean up the mess afterward. So physics always trumps our preconceived ideas about climate change. We've got to pay a lot of attention to them. While Project Drawdown, we've organized our thinking around climate solutions in that way, of course. We've organized a lot, especially in the most recent work of our Drawdown review, which you can download for free on the web at drawdown.org. We've organized our solutions in kind of major areas, those that affect the sources of greenhouse gases right from the beginning, those that can support and maybe enhance natural sinks, and then those that are kind of transforming society in interesting ways that could also have important effects on climate change. We further then break them down into major sectors like electricity, you see in orange, food, industry, buildings, transportation, that's in the sources area where we can reduce the primary sources of greenhouse gases. In the sinks, primarily, Drawdown has looked at sources and sinks in terms of how they affect land sinks. We're beginning to look more and more at the oceans and perhaps even kind of industrial types of sinks in the future. And then around societal transformations, primarily around health and education. We further group solutions into big clusters, like in electricity, those that are about new renewable electricity production, and those that are related to energy efficiency. Within each of those little pie charts, there may be dozens of individual actions you can take. But these are the big clusters of solutions, organized usually around things like efficiency and transforming the system to a low greenhouse gas alternative. And then we can dive into individual solutions, the ones that we used to rank from 1 to 80. Now we kind of show in these little pie charts or in different ways, kind of showing how they're organized. The bigger the wedge, the bigger the solutions. Here are solutions related to electricity, to food, industry, and then so on, food, buildings, transport, materials, and so on. We can also see solutions related to sinks over here and things like that, especially on land, and of course, the ones related to health and education, especially health and education that levels the playing field between men and women and boys and girls around the world. But together, the original kind of drawdown solutions can also be looked at like this kind of pie chart, showing them kind of in context, not just as a list, but how do they fit in as wedges to the whole pie. But what's really important too is to kind of see them all played out together in the same kind of diagram. Again, if we want to reduce sources, we have to do it across major areas like electricity and food and industry, transport and buildings. And the size of these circles are proportional to all the solutions we find there. We also can find ways to support sinks, again, mostly on land, but also increasingly in the ocean and maybe with engineering solutions, and how improving society can have secondary effects back to climate change here. What's really great about the original kind of drawdown analysis of finding solutions is that we've done the math and found that they are enough to stop climate change. If we look at trajectories of greenhouse gases into the future, we can see how the effects of drawdown solutions can actually help us achieve climate solutions very quickly and stop climate change in the coming decades. For example, the red curve is if we do really nothing beyond what's committed already. But the yellow and green curves show us different scenarios where we can stop climate change, maybe as early as the 2040s in a very aggressive scenario, or through to the 2050s and early 2060s. These are both scenarios we've developed, but everything in the middle is also possible. We get to choose which scenario we follow, and it isn't written for us yet. But the changes in temperature that would result, of course, are corresponding pretty much to the Paris Accords. The red curve sees warming continuing above 2 degrees towards 2.5, heading towards 3 degrees and maybe beyond by the end of the century. But in the yellow and green curves, these scenarios we've developed in Drawdown, we see that with drawdown solutions, with existing technologies, with nothing new, we can stabilize Earth's temperature roughly between 1.5 or 2 degrees of warming. Those are choices that are still available to us. But these solutions don't happen by magic. That's the really important thing to recognize. Solutions that Drawdown describes are existing technologies and practices that are available today that don't need to be reinvented or created from scratch. They're already here. And we think that they're also economical, but they don't happen by themselves. We have to deploy these solutions. We have to make them scale and get bigger into the world. But we call that process accelerators. Solutions, again, are physical things that affect the level of greenhouse gases in the air. Accelerators are the things that we in society do that make them get bigger and scale up in affecting climate change. Some of the key accelerators we look at are basically changes in policy or the rules, how we change laws, regulations, taxes, incentives. This is kind of the role of government, from local governments, which are very important, to states, federal governments, international agreements, and so on. We have to shift capital as well, move billions and billions of dollars, well, trillions really, out of bad things like oil and fossil fuels, industrial agriculture, and so on, and move them into good things. The tip of the spear here might be philanthropy, impact investing, kind of a long vision money that could go into good things that will pay off in the long run. We also have to change the rules of business. So the goals and kind of incentives that businesses follow, that markets follow, are in line with climate change solutions, not with destroying the planet, but with maybe making it better. We also need better technologies, not to create new technologies necessarily, though that would help. We would love to add more drawdown solutions. But what's even more important is taking the solutions we have now and making them cheaper and more scalable so that they can actually get to the size they need to be rather than just at the lab bench. And of course, we also need behavioral change at the level of individuals, communities, and all of society, because what we do actually matters a lot too. What's interesting is these accelerators are sometimes tied to our own kind of theories of change. You notice how some climate activists really kind of latch onto one accelerator, like policy at the federal level gets a lot of attention right now in the United States, for example, or behavior change at the individual level, or business change, or investor change. Somehow people tend to think these are just one lever we can pull to address climate change. But in reality, like Drawdown shows, there's no one solution to climate change. There's no one accelerator to scale them. We probably need them all. So again, in Drawdown, we tend to look at portfolios of solutions on kind of one axis and portfolios of accelerators on another. And together they kind of play out the whole, if you will, chessboard in which we'll play this game to address climate change. And we have to do this over time. As we begin to think about implementing climate solutions into the future, I like to think about how we'll deploy them through the next 2-3 decades, starting now in the 2020s, through the 2030s, into the 2040s. And at each era, we may have different waves of action, different things we'll be focusing on more than at other times. For example, right now, it's crucial that we begin to move the needle as quickly as possible. And there are things we can do now that will buy us a lot of time. And there are things that are kind of the low-hanging fruits that are still available, especially things that are cost-effective. There's really no argument at all about doing them today. Like energy efficiency, still huge wins available in electricity, buildings, transport, and so on. There are huge wins available in food waste, another efficiency measure, or ceasing deforestation. Together, those two could be massive improvements in climate solutions today. Another is focusing on methane. Methane packs a very powerful punch in the first decade or two after it's emitted, and reducing methane leaks, especially point sources and fugitive emissions of methane from fracking or the gas pipelines and things like this are crucial. But eventually we need to reduce methane emissions in agriculture, which means tackling kind of cattle and dairy operations as well. We also can talk about switching to renewables. A few years ago, we might not have said this was cost effective 10, 20 years ago, but today it turns out that renewables are in fact the cheapest form of producing electricity on the planet. These numbers are already out of date. They're about a year old, and wind and solar have gotten even cheaper and are far cheaper today than gas, coal, and certainly nuclear, making them the best kind of sources of electricity today. And in fact, this is what we're seeing in the United States during 2019. The last year, we have good, complete data so far. About half of the new electricity being produced today in 2019 was from wind, another 20% or so is from solar, some natural gas, yes, but what's been retired has been coal and nuclear and natural gas. So as we gained 24 gigawatts of generation capacity, we lost about 8, but the mix is definitely shifting to be predominantly renewables with some gas, away from primarily coal and gas and nuclear. We also have to think about beginning today and going into the next decade or two, some long-term infrastructure changes. Getting to Drawdown requires that we change a lot of big things, including the way we farm. Every farm, every ranch, every cropland in the world will have to change to be more sustainable, maybe more regenerative forms of agriculture, things that will not contribute to climate change. This will take time. Every building in the world will have to be remodeled. Every form of transportation will have to be rebuilt. Everything that we have, every furnace, hot water heater, internal combustion engine, jet engine will have to be scrapped, replaced, and renewed with something better. And then along the way, we'll need innovative new technologies that help us scale existing practices so that they're cheaper, more ubiquitous, and easier to use, make them the standard, basically, around the world, but also develop some new technologies that we need to have in order to kind of move forward very gracefully. For example, in industry, we need to find better ways of making carbon-free cement, better refrigerants, carbon-free steel, things like this. In transportation, we may need to have kind of drop-in replacement for jet fuel, so take carbon pollution out of the air, not from oil or out of the ground, but take last year's pollution and turn it into this year's jet fuels, or plastics or building materials. And if we think about this kind of layout of different kinds of solutions, kind of following out on different timescales, low-hanging fruit efficiency wins today, long-term infrastructure changes that could create hundreds of millions of jobs that can't be outsourced or turned into an AI algorithm, and then long-term scalable technologies that could create new opportunities for business and investment. This is an incredible opportunity for the world. I believe that taking climate change on seriously is the biggest kind of business and economic opportunity and job creation opportunity in history, as well as being good for society and the planet. It's not that we have to, just, it's like a chore to reimagine the world. We get to with solving climate change. We get to fix a lot of our broken systems. And as we do, we can also address a lot of our more systemic societal issues around equity and justice and other things that are crucial to our future. So affording climate change solutions and putting them out into the world actually affords us the opportunity to reimagine the world and make it better. And as we move forward through this conference, here's my ask of you. We need to do this together. No one organization or group or individual certainly can do the work of addressing climate change. We all have to work together. And we have so much to learn from each other. And we need to learn and share so much more across all the kinds of organizations here today. But also it's crucial that we exercise our leadership at all levels and with all these accelerators I talked about. Whether you work in policy or business or investors or culture change or movements or all of these different things, we need leadership at all levels, from local to global, across all forms of accelerators. So please exercise your leadership in wherever you can find it. And most of all, remember that the future is not necessarily grim. It's still up for grabs. We get to decide what the future is going to be. I love this quote from Robert Wilson, who said, "The future is up for grabs, and it belongs to any and all who will take the risk and accept the responsibility of consciously creating the future they want." So I hope we can leave this conference today with that sense of purpose of building a better future, a more equitable, more sustainable, and climate-safe future for ourselves, but also the generations that come after us. We have the tools we need. We know how to deploy them with different kinds of accelerators. And what we have to do is step up and make them happen. So thank you very much. And I look forward to seeing you through the rest of this conference. Thank you.